How's everyone doing today? Hey, thanks for coming into the live stream. Okay, I'm gonna go over. I think I've had three questions so far. So if you have any other questions, just throw them into the chat, and I will go over those as well. Okay, and let me know if the mic is too low or anything like that. It looks okay, but just let me know one way or the other. Okay. All right. So first question that came to me about this new material, which if you want a quick recap of what that was, both of them were on this worksheet. Okay. So you guys did the problems in this 1 through 12 section, and that's what I gave you some practice on. Okay, and then the next ones, let's get the numbers for the next ones. So the next ones were on the same worksheet, and you did, where'd it go? You guys did 13, 14, 20, 25, 27. So a little bit later on in the worksheet in the second half. So we're going to start off with the first half. There were two particular questions that people had about numbers in that first section. Okay, and then someone also just asked me to go over what an extraneous solution was, just generally kind of what was going on with those. Okay, so I'm going to start off with extraneous solutions because it's entirely possible that they might show up in the problems that I'm going to go over. So starting off with extraneous solutions, here's the idea with an extraneous solution. I'm just going to give you like a general kind of case on this. Okay, if you ever, when you're solving radicals, come across a problem and at the end it looks something like this. Well, not at the end, but anywhere in the process looks something like this. If I had like 2x plus 1 equals negative, we'll say 5 or something like that, right? And you get to this step of your problem. Here's the issue. Okay, the square root that's on the left here, whatever I square root, okay, is going to end up being a positive number, right? So in this case, it looks like if I were to plug in like a 12 here, right? If I were to plug in a 12 here, I'd get 24 plus 1, which is 25. And then I'm going to square root 25, but that result is always going to be positive. And on the right-hand side, we have something that's negative. This is something that can never work out. I will always get a positive number on the right. I will always have a negative number on, I will always get a positive number on the left, and I have a negative number on the right, and so this is something that can't happen. If we were to finish this problem, which I'll just do it kind of real quick, if I square both sides, right, here's what I end up with. The radical and the squared symbol will cancel, and I'll just end up with the 2x plus 1, okay? And on the right-hand side, I'll do negative 5 times negative 5, which is 25, okay? And then I'll subtract, and I'll get that 2x is equal to 24, okay? And then I'll divide both sides by 2, and I'll get that x is equal to 12, okay? And so that would be my supposed answer, but we just said a second ago that if I take this 12 and plug it back in, I get 2 times 12, which is 24, plus 1, which is 25. And if I square root 25, the answer to this is going to be positive 5, and that is not negative 5, okay? So even if we're going through this problem, okay, if I come across the problem that has a step like this, okay, I don't have to go any further because I already know that this is not going to work out. The left-hand side's positive, the right-hand side's negative. At this point, I can just say there's no solution to this problem, right? There's no way for me to square root something and end up with a negative answer, okay? So that's an example of an extraneous solution. And then you also see some, as you're solving some of the other problems that we're going to do, that sometimes you'll get two answers, and one of them will work and the other one won't, right? So that's what we're going to end up seeing, I believe, right now when we take a look at problem number 7, okay? So problem number 7, if I were to look at this, I would say right now the left-hand side is a radical, but the radical's by itself. There's nothing on the outside, right? So at this point, I'm good to just square the left-hand side, okay? And that's going to make the square root and the square cancel, and I'll end up with x plus 7, okay? And then on the right-hand side, this is where things get a little trickier. This is why I call this advanced radicals, okay? And that is because this entire x minus 5 has to be squared, okay? And just to remind you, that means I have to do x minus 5, okay, times another x minus 5, okay? And if I multiply all this out, here's what I'm left with, x squared, okay? And then I'll get a minus 5 and another minus 5, which is minus 10, okay? And then negative 5 times negative 5, and that's going to be plus 25, okay? And so now I have to solve this problem, and the way I'm going to do that whenever I see a squared show up is to subtract everything over and set it equal to 0. So I'm going to subtract this x over, Okay, the x squared is not going to change. Okay, but then if I subtract negative 10 minus 1, I'll get negative 11. Okay, and if I subtract 25 minus 7, I'll get positive 18. Okay, so this is plus 18. Okay, so this is the problem that I have to solve, and this is something that I can try to factor. If factoring doesn't work, I'll have to try something like completing the square or the quadratic formula. Most people will probably do the quadratic formula, okay? And so in this case, this one does factor nicely. I can say negative 2 times negative 9. This is negative 2 plus negative 9. So I can break this up into x minus 2, okay, and x minus 9, okay? And that's going to be equal to 0, okay? So I get two answers. If I set the first factor equal to 0, I get a 2, okay? And if I set the second factor equal to 0, I get a 9. Okay, and so those would be my potential two answers. Okay, we have to check them though, right? So if I check this, let me get rid of my writing up here so we can look at the original problem. Okay, if I check this problem, when I plug in the 2, I'm going to get 2 plus 7, which is 9. The square root of 9, that's 3. Okay, if I plug the 2 in on the right, I get negative 3. So this is a case where this 2 does not work. Okay. If I check the 9, okay, here's what I get. Okay, 9 plus 7, well, that's 16. Okay, oh, square root of 16, okay, which is 4. Okay, and then 9 minus 5, that's also 4. So this one is good. Okay, so I'll say x equals 2 is extraneous because it made it that whole 3 negative 3 situation, but the 9 is okay. And so that would be my only final answer for that one. Okay, so is there any questions on something like 7? Because the one I'm about to do is pretty similar with one kind of twist. Okay, so if you have any questions about this one, just pop them into the chat. Okay, I'm going to move on to the next one. Okay, the next one is problem number 12, which is very similar with the one exception that before you can square, like let's take a look at this one real quick. The very first thing I did was square both sides, and I could do that because the left-hand side was just the radical, nothing on the outside. On the right, this plus 6 is an issue. So the first thing I need to do is move the plus 6 to the other side and make it a minus 6. Okay, so it'll look like the square root of x equals, and then x minus 6. Okay? And that would be my problem. And now if you notice, if I take a look at this problem, this step right here, right, on my original first step, now looks very similar to the one I just did, right? So the only difference between 7 and 12 is that on number 12, you had to clean it up first and get it to the point where you could square, where number 7 was already ready, okay? So now I'll just do this one real quick. So we'll square, okay, and we'll square. So the left-hand side just has x because square root and square cancel. And I'm not going to show the work for this one, but you can check it if you need to. It's x squared minus 12x, right, because negative 6 and negative 6, okay, and then plus 36 when I multiply those negative 6s, okay? So now I'm going to subtract over my x, and I'm going to get x squared minus 13x plus 36, okay? And again, I got to do a little thinking about what multiplies to what multiplies to 36, okay? Positive 36 that adds to negative 13, okay? And then my answers in this case are x minus 9, okay, and x minus 4, okay? So I'll get two answers, again, potentially two answers. I'm going to get a 9, okay, and I'm going to get a 4. Okay? We have to check them, though, because extraneous solution means it's got to work after you plug it back in. So the first one says the square root of 9, okay, the square root of 9 is 3 plus 6. And on the right-hand side, I'm just going to plug in the x again, which would make that 9. That one's good. 3 plus 6 does make 9, okay? For the 4, if I plug that in, it'll say the square root of 4, which is 2, plus 6 equals 4, okay? That one doesn't make a whole lot of sense. That says 8 equals 4. This one is bad, okay? So I'm going to take that one out of the equation. So my only answer for this one is that x is equal to 9, okay? So those were the three things that people asked me to go over to just kind of highlight what extraneous solutions were. Done, okay? And then number 7 and number 12, okay? So is there anything else that we want to go over either on the 5 original problems that I gave you 2 days ago, right? Which was I gave you yesterday, which was practice. And that was, again, to remind you, besides 7 and 12, okay, that was 4, 5, and 11. Those were some of the other ones, okay? And then on the homework, okay, the one that's going to be due due tomorrow, right? I posted it yesterday. Okay, it's due tomorrow, right? So on those ones, we had 13, 14, 20, 25, 27. So let me know what you want to go over. And again, if we do the homework problems, I'm not going to do I'm not going to do that exact problem, but I'll do something similar. Number 60 on 6-4. What is that? Number 60. Do we have a number 60? Oh, or is that yesterday's work? Let me check. The previous days. Let's see. No, 7-7. Is that an old homework 6-4? The 50 to, was that like a 50 to 61, I think, or something like that? Let's see. So let's see, about 50 to 61. Rational exponents, part 2. Okay. Okay, so let me pull that up real quick. So 50, number 60. Okay. So it's on this side. Okay, I got it. So just so you know, if you are in my period G class, this is not going to make any sense, but it's good to see it, okay? So if you wanted to, this is what we would have done in Monday on the day 6 that we weren't here, okay? So let me snip number 60 into the thing here, okay? Something similar to 13 and 27. Yes, we can, okay? So let me do this one rational exponents one. So again, if you're from my period G class, this is going to be a little advanced, but it's something that's good to see, right? Because you might be able to pick it up, okay? All right, so here's problem number 60, okay, I believe. Let me know if I'm wrong, okay? So for a problem like this is our going back to rational exponents. So the idea with this is we want to combine all the x's and all the y's, okay? And here's something that's like an old exponent rule. Negative exponents, what we're going to do is move them in the fraction, right? So I want to put these x's together and these y's together. Okay, so the way that I'm going to do that is take this negative 1/3 and move it down, and I'm going to take this negative 1/2 and move it up. So it'll look something like this, okay? The negative 1/3 will move to the bottom, so the x to the 2/3 is staying right where it is, okay? And then the x to the 1/3, or negative 1/3, is going to move down there, right? But when we do that, it will be positive, okay? And then I'm going to do the same thing with the negative 1/2. This negative 1/2 will move up, so that original y will be there, and then the negative 1/2 will move up and become positive 1/2, okay? And then this like big 2 is just still sitting out there, right? So what I'm trying to do here is just simplify the x's and y's as much as I can before I bring that 2 in. If you brought the 2 in at the beginning, that's fine. You'll just be dealing with slightly different numbers, okay? So right now, since these y's are next to each other, I can add the exponents. So right now, this one is just like, I'll make it 2/2, right? It's really 1. Sorry, my writing is still atrocious. I will get this better, okay? All right, so this is, I need to add these exponents. So if it's 1, I can write that 1 as 2/2. So if I add these together, that's going to be equal to y to the 3/2, okay? And then on the bottom, this one right here is going to be 1/3 plus 2/3, which is 3/3, right? So 3/3, which I'm going to write, 3/3 is really just 1, right? But we'll fix that, okay? Still squared. So I combine my x and my y's, okay? And now, okay, I'm going to give this 2 to both of these, okay? So here's what it'll look like, okay? So the denominator is really x to the first power, and if I multiply this 2, right, that'll just make this bottom one x squared, okay? And then x to the 3/2, okay? 3/2 times 2 is just going to be 3, right? 2/1, right? The 2 on the top and the 2 on the bottom will cancel. So this will just become y to the 3rd, okay? And that would be the final answer. So that one is done because no negative exponents, no radicals in the denominator, and no repeated bases, right? X and y only show up once each, okay? So does that answer your question about that one? Does that kind of make sense? I know sometimes the exponent rules are a little bit, they're older. We haven't spent a lot of time on them, so keeping up with those is sometimes a pain, okay? All right, so something similar to 13 and 27. Okay, so 13 is very similar to the number 7 that we just went over. So let me go back to the number 7 real quick, okay? So if you take a look at number 7, right, this has a radical on the left, okay? And it's got an expression on the right, right? My expression's x minus 5 for problem number 13. If I snip that one in, okay, is, okay, and I'll copy it over, right? So if we see these side by side, you can kind of see, like, they have the same setup, right? So if you follow the process here, we're going to do something almost exactly the same. Here's the one thing I will help you out with. When you square the right-hand side, okay, this thing, okay, here's what it's going to look like. Again, you're going to do something very similar to this. So you'll do 10 minus x and another 10 minus x. Okay, so it's a little bit backwards. Okay, but we can still do the same thing. You're going to do 10 times 10, which is 100. Okay, I have 10 times negative x, which is negative 10x. Okay, another negative 10x from this one. Okay, and then negative x and negative x makes positive x squared. Okay, and then if I put this together, it's going to say 100 minus 20x plus x squared. And if you're not comfortable with it all being backwards like this, you can rewrite this. Positive x squared can go first, okay? Then the minus 20x. And then 100 is positive, so I'll put plus 100, okay? And I can have this on my right-hand side, which would be very similar to like this one right here. Then you're going to subtract over the x plus 2 and then solve from there. And I'm trying to see if that works. I believe it works out nice. Let me check my answer key real quick. Number 13. Yeah, 13 does factor nicely. You just might have to do a little searching because 98 is not a super nice number. Okay, and there is one extraneous solution for that one. Okay, so if that helps you out, if you want any like additional how to do it, do that exact problem. Maybe I'll make a quick video and do some of these answer keys if I have time. But hopefully that helps. Okay, and then 27. Ooh, I don't even have my answer key for 27. I'm going to have to do this one live. All right, so let's take a look at 27. So 27 is... Okay, 27 is, again, it's very similar to this exact same process. I will, since I don't have the answer key in front of me, I will do 27 with you, okay, to help you out. Okay, so I'm going to snip this one in. We'll do this one. And then again, if anyone else, while I'm doing this one, if you have any additional questions, right, just put it in the chat and I'll queue it up so we can keep going instead of having to wait. Okay. All right. So problem like 27. Okay. Very similar again. If I look at the left-hand side, the radicals by itself, right? So I don't have to do a whole lot to the left. This thing's ready to be squared. So I'm going to square the square root. Okay. And I'm doing that so I can get to this x plus 2. And that means I need to square this thing. Okay. And so that's going to be x squared minus... If I do negative 18x and another negative 18x, that's negative 36x, okay? And then I got to grab my calculator because I don't know my 18 multiples, okay? Let's see, 18 times 18. That looks like 324, okay? So positive 324, okay? And then I can just subtract this stuff on the left. Again, once I see that squared, my first instinct is always to try to make it equal 0. So if I subtract this stuff over, here's what I get. 0 equals x squared minus 37x, okay, and then it's plus 322, okay? So again, these are kind of big numbers, right? And you might have questions about whether or not these are factorable. It probably is, but you might have to just do a little bit more searching. So let's just cheat a little bit and let Google do the work. Let's see if I can find factors of 322, okay? So 322 has a 1 and a 322, which doesn't work, a 2 and a 161, which doesn't work, 14 and a 46, which does not work, okay? The last one, though, there it is, 14 and 23 do add to 37. So those are the ones that I like. So for a problem like this, I'm going to say x minus 14, okay, and x minus 23, okay? Because those do multiply back to 322, and then if I add up these numbers, I'll get a 37, so that looks good, okay? All right, so this one's going to be x equals 14, which is maybe an answer. And this is x equals 23, which is also maybe an answer. So let's just do a quick check, okay? Get rid of all this, okay? All right, so if I plug in the 14, I get the square root of 16, okay, which is 4, okay? And if I plug in 14 here, I get 14 minus 18, which is negative 4. That one's no good, okay? For this one, though, if I plug in the 23, I get 23 plus 2, which is 25. So the square root of 25 is 5. And if I do 23 minus 18, I also get a 5. So that one is good. Okay, that's going to be my only answer. Okay. All right, so is there any questions, any other questions either on the original paper that I gave you when I assigned the video for your practice? I gave you an answer key for that one. Or the new 5 problems that I gave, which I didn't give you an answer key for, but I'm happy to go over any of those topics if you're struggling a little bit. Okay, and what I might do going forward, depending on the type of problem, is I might just give you what the answers are. Like I won't give you the work, but that's something that for at least for those homework problems, just so you can kind of see if you're on the right track. If you're completely stuck, I'll at least tell you what the correct answers are, so you can make sure that you can get from the beginning to that answer. Okay. So, any other questions? Okay, and if you, I'm gonna post it again, but if you have a chance, okay, and I posted a Google form, and it looks like I've had 6 or 7 people respond, which is good. Okay, just to get some feedback on kind of how you're doing with the material, just on a scale of 1 to 5, 5 being like I nailed it, I know exactly what's going on. If you just click on that Google Forms link, that'll let me know if I'm ready to move on or if we need to spend a little bit of extra time on something. Okay, and if you're watching this like via video later, the form will still be open. So even if you're not watching this live right now, you can still give me that feedback because again, that's going to let me know since we're not really moving at a pace. I can actually move at a, you know, what's going to help you guys most pace instead of we have to rush through it because June's coming. So most people right now have said 4 or 5, which is good. Sounds like it's working out. But if I ever get a feedback that this is going completely over people's heads, we can spend an extra day on it, and I can maybe do some extra example problems that might help you out. Okay. So I'm haven't gotten any additional questions, so it sounds like everyone's okay. I'm gonna just throw on my annoying electronic music in the background and mute my mic and do some other work, and I'll be here for the next 20 minutes or so. Okay. Um, yep. Okay. There you go. Okay. So let me know. Okay. So I'm going on mute. All right, number 20. Let me pull up number 20. Let's see. Says I need permission for the form. You might have to be logged into your CHCLC account for the form. If you're logged into like your personal Gmail, that probably won't work. Okay. Okay, so problem like number 20. Let me look at that one real quick. So 20 is 3x minus 3 minus x. Okay, so I'm going to point you to one that we've already done because it's very similar. So we actually already talked about, okay, here it is. Okay, we talked about this one right here. So if you take a look at number 12, I would say 12 and 20 are almost the same thing. Here's the kind of one catch. Well, let's kind of see them side by side. So let me snap 20 in so you can see them both. Okay. So if you take a look at 20, okay. All right, here we go. Okay. So problem number 20, you can see that it's kind of the same thing where in this case there's like something outside of the radical, and the first thing we did was subtract that 6 to the other side. Okay, and then that allowed us to get the radical alone, and then I could square both sides. Okay, 20 is the same kind of thing. The only difference is that this one's actually probably, I think, a little more advanced because there's an x over here as well, right? So you had to square this whole expression. You're just going to add that 6 over, okay, and then the radical will be alone, and then you can square both sides. But the nice thing is, if it's just 6 over there and you just have to square 6, it's not going to be like this kind of crazy FOIL. It's just going to be squaring 6. Okay, so give that a shot. I think like from there on, it's pretty straightforward. After you square both sides, you'll then just kind of get rid of the rest of like the 3x and the 3. Okay, so any particular questions about that one, or does that clear it up at all, Brennan? Okay, cool. Okay, cool. Awesome. All right. Any other questions? Anything else you want to go over? Just again, I'm monitoring the chat. I'm just muting my mic because there's a baby in the house, and sometimes I have to go check in on her and stuff like that. So I'm around. Again, the stream is just going to be open until noon, and I'll be monitoring the chat. You too, Brendan. See ya. Hey. So let me know if any other questions come up. Anything else we want to go over?